So one solution here, to get into maybe the quasi-technical, is to look at breaking up the pieces of these systems, particularly for storage-intensive compliance and forensics deployments. So we can disaggregate the function of these systems, looking at storage and processing and analytics as separate components. Storage that is independent of the network management application enables users to choose the system that maintains the physical store and the data available for use beyond a single application. The advantage of decoupling or breaking apart these functions is that the data is returned to the network owner, and it can be aggregated and pre-processed for use within the organization's data platform or storage infrastructure. And this reduces costs and just makes people more efficient. Okay, I'm going to explain here in the next slide a bit about how this is a natural progression for NPBs. Traditional network monitoring tools had sort of a one-to-one relationship to the network. They were hung off span ports. They were deployed in line using a tap, often one probe per segment. Hardware-based capture with kind of front-ending tap ports, filtering, write-to-disk, processing, retrieval, analysis, all these things were handled by one system. The systems had to be local to where the traffic was, so you had system on each segment. That drove up costs. And these systems necessarily had to process traffic that really wasn't relevant to that specific application, so they were burdened with processing they didn't need to do. Sometimes they couldn't see packets or they dropped packets, and that led to blind spots. If we look at the current model, one piece of what was once integrated with systems has been pulled out. In the last several years, we've enabled network monitoring to move away from a purely tap and span approach to capture. Network taps incorporate high-capacity aggregation, speed conversion, filtering, and today, the advanced intelligent pre-processing has been offloaded from those tools into what we now call network packet brokers. Pre-processing, including timestamping and packet deduplication, microburst detection, high data burst buffering, other capabilities as well. These optimize the usage of those tools. In most large-scale networks, network packet brokers are capturing and grooming vast amounts of network traffic for a wide range of network tools and security systems. This change allows network owners to maximize efficiency and reduce tool costs. The tools see more traffic, and at the same time, unnecessary traffic is filtered out. Network tool issues such as packet loss, over or underutilization, unnecessary processing, they can all be eliminated by applying a visibility plane, by deploying network packet brokers. So this shift to decouple capture and optimization has had a significant positive effect on network monitoring, not only in terms of economics, but also in terms of reducing the workload of the people who have to actually operate the networks. The tool vendors, they gained advantages as well. They can meet previously unachievable scale. They can deploy in production environments operating at much higher speeds. So the current model is critical to scaling network visibility across both carrier and enterprise networks, and networks benefit from this new approach to capture and delivery. Network packet brokers today act as a transparent proxy for network probes. But storage constraints, these remain unaddressed. For all the improvements we've made, there's still waste and inefficiency, particularly when it comes to the replication of packet storage and the inflexibility of closed storage appliances. The next step then might be to look at file creation as something else that we could pull out of the closed systems and do in an open way, in a larger scale manner. The network has changed quite a bit over the last couple of years. Hardware has become faster and cheaper, and commodity storage platforms have emerged. New networking models are really being embraced. Big data technologies and architectures are changing how data is handled and delivered. In particular, a shared model is emerging where data is available to multiple applications and stakeholders. And by moving file creation to another place in the larger architecture, by making file creation part of the capture and delivery infrastructure, we can accelerate this change. In this environment, tightly integrated hardware and software tools are less attractive. The capture and optimization layer, the NPBs, now have the sophistication to create files just as they were streaming packets. Storage has become cheaper. Large-scale data processing has become viable. So a network analytics model that aligns with these new networks is one that needs capture and storage and processing and analysis functions to be separated. The network packet broker layer can now perform capture and optimization, as well as packaging all those network packets into a file and eliminating the need for specialized network interfaces to process those packets and tuck them away. Doing so increases the range of servers capable of receiving and storing network data. After the data is on an open storage platform, it can be acted on by network analytics applications or by an intermediate pre-processing framework that serves the data up to tools. VSS Monitoring has implemented a file creation and offload capability in its platform. This functionality is called vSpool. vSpool generates PCAPs and delivers them over a standard storage protocol. A PCAP has the advantage of being in an open and non-proprietary file format. The PCAP encoding makes network data available to multiple tools, freeing the data. The ability to create files from network data is a natural progression for this visibility plane. Filter the data, optimize the data, deliver it to tools, and store it for later use. It's really that simple in a sense. So here I've gone on for a bit. I think we're going to stop and do a vote on a survey we've got here.